Good morning guys and welcome to my channel Mind Your Math. Today we are going to talk about competency based questions. Now these are a set of questions which are published in the CBSE academic website. This is the official website which we normally use for CBSE related study material or for question papers etc. Now these competency based questions are given for all the chapters. We are going to talk about the first chapter which is real numbers and we are going to talk about the first 5 questions which are the MCQs. Now these MCQs are of 1 mark and these competency based questions, they are different from the normal questions that you see in the reference book or in your textbook. These questions, though they are very basic, they require a thorough understanding of the concept which are explained in the first chapter. So now let us start with the first question and see whether we actually know the concept which are given in the chapter 1. So now you have read the first question, which is if p is a prime number and if p divides k square, which of these numbers are divisible by p? Now a few options are given to you. We will get to the options now. Now, as soon as you see this question, you should be able to relate it to a theorem which is given in your textbook, which is that if p is a prime number and p divides a square, p divides a. Fine. So you know that if p divides k square, p has to divide k. So k is divisible by p. Now, you know that 7k is just a multiple of k. So if k is divisible by p, 7k also has to be divisible by p. Correct? So this is also divisible by p. Now, next one is k cube. Now, what about k cube? K cube is actually k into k into k. There are 3 k's. We know that k is divisible by p. So, k cube also has to be divisible by p. Now, one number is pending, which is k by 2. What happens with k by 2? The value of k is divided by half. So, we cannot conclusively say whether we can divide k by 2. We are not sure about it, or actually let us say that it cannot divide k by 2. So, these are the 3 numbers which are divisible by p. Now, let us solve the second question. It is given that root of n is a natural number and the value of n is greater than 1. We need to see how many of these are or can be expressed as the product of prime numbers. Fine. Now, in order to express any number as a product of primes, we need to have that number as a natural number. Only natural numbers can be expressed as the product of primes. So that is our first concept that we need to remember. Now, root of n is a natural number. Okay, so n also has to be a natural number. So n is a natural number which is greater than 1. Fine. So I definitely can express n as the product of primes because n is definitely a natural number. Now, root of n is given to be a natural number, so I can express root of n also as the product of prime numbers. Okay. Now, this both can be expressed as a product of primes. What about root of n by 2? Now, guys, whenever you are having a doubt regarding a particular concept as to whether it is true or not true, you just need to find one example to disprove it. So, root of n by 2, as a teacher, I know that it cannot be expressed as a product of primes. As a student, if you are having any doubt, just let n is equal to 9. What happens to root of n? It becomes 3. What happens to root of n by 2? It becomes 3 by 2, which is not a natural number. So, root of n by 2 may or may not be a natural number depending upon the value of n. So, root of n by 2 giving a fraction, we cannot say conclusively in all the cases root of n by 2 will be a natural number. So, it cannot be expressed as the product of primes. So, only root of n and n can be expressed as the product of primes. Our third question is based on the concept of HCF. Now, HCF is the highest common factor. So, you know how to find the highest common factor of two numbers or more than two numbers. Now, the third question says that the HCF of K and 93 is 31. Okay. Now, which of these can be true for some values of K? So, it's kind of a sketchy question. The only fact we know for sure is that the HCF of K and 93 is 31, which means that I can write K as 31 into X and 93 as 31 into Y. Correct, because 31 is the highest common factor between K and 93. So this fact cannot be disregarded under any circumstance. So which of these can be true for some values of K? The first one, K is a multiple of 31. It is true because otherwise 31 cannot be the HCF of K and 93. K is a multiple of 93. Now let me rewrite it. If K is a multiple of 93, what will become the HCF of K and 93 now? It will become 93. So, the only fact that we know in the question that 31 is the HCF of K and 93 will not be valid anymore. So, this condition is not possible, which is K is a multiple of 93 is not possible. Okay. K is an even number and K is an odd number. So, for some values of K, K can be even. For some values of K, K can be odd. We cannot conclusively say because we do not know the value of K. So, K is a multiple of 31 is true. K is an even number is true. K is an odd number is true. The reason being for some values of K. So, we are not telling all values of K because in that case, we do not know whether K will be even or odd. Some values K can be even and some values K can be odd. So, 1, 3 and 4 are the correct answers. The fourth question where P is divided by Q giving R as a remainder is based on division, our basic division. Now, what is the basic concept in division? Till which term do we divide two numbers? We divide the numbers in such a way that the remainder should not be equal to or greater than the divisor, because if the remainder what we are getting is greater than the divisor, we can again divide. Even if it is equal to the divisor, we can always divide again. So the condition is that the remainder has to be always lesser than the divisor, the point at which we stop our division. This is basic maths, which I have also explained in the video, which is the tutorial on real numbers. So here, if P greater than Q, P is divided by Q, it is giving a remainder of R. These are our three options. We know that the remainder always has to be lesser than the divisor, which means that R has to be always less than Q. So this third one is definitely correct. Now let us check the other two. R can be Q or P minus Q. Forget about P minus Q part. Can R be equal to Q? I just told you that R cannot be equal to Q because if R is equal to Q, we have to continue our division. Can R be equal to P minus Q? Now we have to check that because one is contradicting the second statement, but the second statement we cannot take because R cannot be equal to Q. Fine. So this is also wrong. R cannot be P minus Q. So how do we decide whether R can be P minus Q? So you know that dividend is equal to divisor into quotient plus remainder. So here our dividend is a P, divisor is a Q. I am writing the quotient as such plus R. Fine. Now what is our R equal to? P minus Q into quotient. Correct. Now if the quotient is 1, what happens to the remainder? It becomes P minus Q. Can you give me a very basic example? 4 divided by 3. Our remainder is 1. What is P minus Q here? This is our P, this is our Q, and this is our R. Here, the value of P minus Q becomes 4 minus 3, which is equal to 1. So, in certain cases, the remainder can be equal to P minus Q. So, I cannot say R cannot be P minus Q. So, this is also wrong. So, which is our only correct statement? Our only correct statement is R is definitely lesser than Q. The last MCQ or the fifth one is based on a diagram. So, basically a representation of the number system is given to us. In the entire block, we have real numbers. Inside, in circles, they have given, or in oval shapes, they have given irrational numbers, rational numbers, whole numbers, etc. etc. Now, the first one to start with is a natural number. Okay. Now, when 0 is added to the natural number, we get the whole number. So, you can say that natural numbers is a small part of, or natural numbers plus 0 will give you a whole number, or natural numbers falls inside the whole number thing. Fine. Now, when I am adding negative numbers to the whole numbers, I am getting integers. So, whole numbers is a basic part or a small part of integers. Now, when I am including P by Q form, I also get rational numbers. Okay. But you know that rational numbers are different from irrational numbers, because irrational numbers and rational numbers are two separate representations. So, I cannot say irrational numbers are a bigger part of rational numbers. So, according to this, which of our representation is correct? It is the first representation where irrational numbers is represented as a separate entity but still falls under real numbers.